Good morning or evening or whenever you guys are watching this. We're in week 6 for statistics 9.4 normal distributions. Now, I got your feedback and I understand that standard deviation was difficult for some of you guys. Um, we are, however, going to not calculate standard deviation in the same way this week. In this week, what we're going to do is, now that you know what standard deviation is or kind of what is required to do it in order to find it, I'm just going to give you what the standard deviation is. And then you're going to use standard deviation in order to solve a lot of these problems. You're not going to actually calculate standard deviation like you were doing last week. This time, you're doing something called normal distributions. And normal distributions relies heavily on standard deviations. However, I'm just going to give you that number and you're going to use it. So here, I have the definition: normal distributions, a bell-shaped curve, symmetric distribution with a tail niche. What that basically means is we have a bell-shaped curve like this, right? And a normal distribution is statisticians' way of normalizing things in the real world. And what that means is we need to, in order for stats to mean anything in the real world, we need to find a way to figure out what the normal is. Okay, I don't know if that makes any sense to you, but like for example, if I ran a company and I sold cookies, right, and I wanted to make sure that I'm making the most money, I need to find a way to figure out what's the best um, what's the best size of cookie that I can make, right? If I make a cookie that's too big, I'm giving away too much of my product. If I make a cookie that's too small, I'm not giving my customers enough for what they're paying for, right? So what is acceptable and what is not acceptable? That's when we use a normal distribution. That is what you're going to be seeing in our examples, right? So what do I mean by that? I'm going to put your attention to this, the mean symbol. This is the same mean that we've been using like in week 3 and the last week as well. Um, it's when you add up everything and then you divide it by the number of numbers, right? You're not going to calculate that here. This symbol that I have here that has like an X with a hat on top, right? That is mean. That is a symbol for mean. And in this bell-shaped curve, the mean is right in the middle, okay? And that should make sense because in a normal curve, the mean is exactly in the middle, just like the median. And we're not really going to talk too much about the median here. I want you to focus more on the mean. But just know that that's where we put the mean, right in the middle of the bell curve, okay? The next thing you need to remember is the standard deviation symbol. Remember last week when you did the entire chart and it was like all these numbers, and then you kind of had to figure out what one single number came out, and we called that the standard deviation? Well, this symbol right here that looks like a 6 that's sideways, right? That is the symbol for standard deviation. So whenever you see that symbol, it's a shorthand for saying standard deviation, just like the other symbols are shorthand for saying mean, so I don't have to write the whole word. That symbol is standard deviation, okay? So what you're gonna see when we do this curve, right? A normal curve consists of a bunch of these, right? This curve, by the way, represents 100%. Now I'm going to talk a little bit more about what that means later. But here, what I'm trying to say here is we need to divide 100% of whatever we're trying to figure out into sections, right? And in order for us to figure out if something is normal, the majority of that thing will be towards the center, right? Towards the mean, towards the middle, right? So the majority of that percentage of that 100% has to be clustered around the middle. That's why this graph, everything goes up and then it comes down, but most of it is going to be in the middle. And on the as you get further away from the mean, there's less and less percentages attached to it. Okay. How does standard deviation come into play here? Well, if this is the middle, right? If X is the middle, let's say that X is 5, right? And our standard deviation is, I don't know, 1, right? Every single line you see is going to have a value attached to it, okay? And if my mean was 5 and my standard deviation was 1, we're going to have a bunch of these little equations, right? But I'm going to use this as an example, right? I know that looks weird, what I just wrote there, but just follow me here. X, what that means is mean, right? Mean plus 1 standard deviation. That's what that's a shorthand, that's a math sentence to let me know instructions that in order to find out the value that belongs here, I need to take the mean, which is 5, right? And I need to add 1 standard deviation. Well, if the standard deviation is 1 already, I'm just going to add 1. That means the value here is 6, right? Remember, we read this from left to right. So the numbers all the way to the left here is going to be the smallest number, right? This is going to be bigger, it's going to be bigger, then this is the mean, then it gets bigger, and then it gets bigger, and then it gets biggest, all right? So your job is to figure out all those numbers on top, right? Every single problem, you're going to have this, right? So what about the next one? Well, the next one, we're still going to do the mean, but this time, because this is 2 standard deviations away, it's going to be different. What do I mean by that? This is the mean. This is 1 standard deviation away. This is 2 standard deviations away, right? So 5 plus, and then 2 times, in this case, my standard deviation is 1. So 2 times 1 is 2. 5 times 2. 1 times 2, sorry, which would give us 7. And as you can see, 7 is bigger than 6 here, which checks out because the numbers are supposed to get bigger the more you go to the right. The next value, right, is going to be 3 standard deviations away, right? It's going to be this number. Now, 3 standard deviations, we're going to take the mean again. And this time, we're going to add 3 standard deviations away. We know that in this case, our standard deviation is 1. So 3 times 1 is actually going to be 3. So this will be 5 plus 3, and that's an 8, right? Notice that I started in the middle, and then I went to the right, okay? And because I went to the right, I'm adding a standard deviation. Well, what about the other side? We established that the left side has to be smaller than the right side. So what I'm going to end up doing for the left side is x minus 1 standard deviation, right? So instead of making it bigger, I have to make it smaller. In this case, because we have 5, which is our mean, right? 5 minus 1, and then times whatever my standard deviation is, which is just 1. So 5 minus 1 is 4. We're going to do the same thing for this one, but this time it's 2 standard deviations. Do you guys see a pattern? I hope you guys are seeing a pattern, because you're going to use this curve over and over and over, okay? So I know this looks like a lot of information, but I swear it's not that bad once you know what everything is. So this is x, the mean, minus 2. So the mean is 5 minus 2 times my standard deviation. My standard deviation is 1 in this case. So 2 times 1 is just 2. So it ends up being 5 minus 2. 5 minus 2 is just 3. And you see how it's getting smaller? And that corresponds with the height. The height is also getting smaller. The lower you go on the curve, the value is also getting smaller. I know that's not true for the other side, but just trying to help you out here any way I can. This is going to be 3 standard deviations. And again, 5 minus 3 times the standard deviation, which is 1 in this case. 3 times 1 is just 3. 5 minus 3 is 2. Okay. Now you might be thinking, I don't get it. Why do I need to know this? What's going on? That's a very good question. Why don't we move on to one of the problems and you'll see it for yourself. Okay. The entire curve, I redrew it here so it looks a little better than my previous example. And if you notice, this entire curve, if you want to take a screenshot, if you want to pause the video right now and copy things down, now would be the time, because this is the perfect curve that you're going to be drawing every single problem. I want to see this curve for every problem that I give you, okay? And it's going to be important that you learn how to draw it, because every single problem is going to require that you use it, okay? For these problems, you don't have to calculate the mean, you don't have to calculate standard deviation. I'm just trying to see if you can apply what those numbers are, because those numbers are going to be given to you. And can you apply them to this curve, right? Again, we're taking these things one step at a time, all right? Everything kind of comes together at the end. But the standard normal curve is this. I want you guys to copy it down, everything you see here, right? And I want you to notice that there's something different about this curve than the last one, right? These things. You'll notice that every single section inside the curve has a percentage attached to it, right? And the percentages, that's supposed to be a 2, by the way. The percentages are really important. The percentages also do not change under a normal curve. Under different kinds of curves, there's different rules, but we're not going to go over those right now, right? What you need to know right here is that there are shortcuts that you need to, that are going to be useful later. For example, a normal curve has the following properties. I'm talking about this right here, right? If you notice, there's lines underneath it, right? And that just corresponds to some shortcuts, right? These lines underneath, right, these things are referring to a single word, within, all right? Within or between, you might see one or the other. What this means is, let's say that I have this point, right, and this point, and a problem asks me, okay, from the first point to the second point, what is the percentage of data in between those points, right? Like in between or within those 2 points? Well, if I started here and I go to my right and then I stop here, right? I'm going to count all the percentages that are in between those 2 points, right? So to the right of that first point and then to the left of that point, whatever's in the middle. In that case, if you notice, that's 34% plus 34%. That's where I get this this right here, this 68%. So if you look down here where it says normal curve, about 68% of the data falls within one standard deviation. There goes that word within, right? Notice how I said within one standard deviation. That means that my mean is over here. My mean is right in the middle. To the right of the mean is plus 1 standard deviation, right? To the left of the mean is minus 1 standard deviation. If I say I want to know how much data is within 1 standard deviation, it's between those 2 points. If I say I want to know how much data is within 2 standard deviations, well, I'd have to be talking about this point, and I'd have to be talking about this point, right? In order for me to get the percentage, I'd have to add 13.5 plus 34, 13.5 plus 34 plus 34 plus 13.5, because all 4 of those percentages are in between 2 standard deviations. If I was talking about 3 standard deviations, right, that's this dot right here, plus 3 standard deviations. Notice we see that down here too, right? Minus 3 standard deviations. I'd add up everything. 2.35 plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35, and that gives me 99.7% of the data, and it falls within 3 standard deviations, right? Now, this isn't going to be your answer for every problem. This is just your answer if they use the word within. If they give you specific points, like they say, okay, I want to know whatever, this point is to this point right here, and they just want to know in between this and this, I would take 2.35 and I would add it to 13.5, and that would be my answer. If they just want to know specifically between whatever 2 points, then you'd get those 2 points, and whatever's in between, you add them up, right? I'll get into above and below at the end, but that's pretty much what I want you to understand about this curve. You're going to have to draw this curve the way it was in the beginning before I did all this stuff, right? Every single time, and then you're going to label everything you need to label depending on the problem, okay? So let's move on to the next thing. Let's move on to our problem. What can you expect? The first thing is there's background information, right? The background information reads, the masses in grams of pennies minted in the United States after 1982 are normally distributed. This term, normally distributed, just means that it fits on this normal curve. And you don't really have to worry about it. All the problems you're going to do are going to be normally distributed, okay? Anyways, they're normally distributed within a mean, and you see right here, we have a keyword, mean of 2.5 grams, right? So before I even finish anything, I know that this curve, you see how like I kind of drew this curve and I kind of drew all the lines. I put the X in the middle. Is the mean, this mean right here is 2.5 grams. So I'm gonna write 2.5 right above it because that's my value. Remember, my values go on the outside. My percents go on the inside, okay? The values are what you guys have to find for every problem and put them on this graph. The percents will never change. The percents will be the same every single time. Meaning that before I do this problem, I should always have my percents labeled. Because they're never gonna change. There are some slight variations. If you go online and you find some more accurate ones, there could be some slight variation between them. I chose these percentages because they're a little easier. In case you can't tell what my writing is, that's 2.35 and it's the same on both sides. 0.15% is less than 1%, okay? Okay, so those percentages will never change. The values will change with every problem though, so be careful. Those things are gonna change, right? Okay, then let's go back to the background where it says the mean is 2.5 grams and the standard deviation is 0.02 grams, okay? So we know that every single line I'm either gonna have to add 0.02, depending on if it's on the right of the mean, or if it's on the left side of the mean, I'm gonna have to subtract every single time. Okay, so let's label the bottom, right? Let's do x plus 1 standard deviation. So I know that in my head, I need to add 1 standard deviation. This one, this next one that's next to it, x plus 2 standard deviations. So I need to know I need to add 2 standard deviations to this value. The third one would be the mean, and I'm going to add 3 standard deviations to that. These are all adding because they're to the right of the mean. To the left of the mean, I have my mean minus 1 standard deviation, my mean minus 2 standard deviations, my mean minus 3 standard deviations. So again, those things on the bottom of that curve are directions for me. They're directions so that I can know how to solve these problems. Okay. Now, our objective, remember, was to fill out this table of values. I need to know what goes on top of each one of these lines. Okay. That's what I'm trying to figure out. Okay. So now, how do I do that? Well, I know the mean. So I start there. I started the mean, 2.5. I'm going to go to the right. To the right, the instructions say my mean, which is 2.5, plus 1 times whatever my standard deviation is. My standard deviation is 0.02. That means 2.5 plus 0.02. So I'm doing that on the side here. So since there's nothing here, I'm just going to add a 0, 2, 5.2. I have 2.52. That is the value that I have here. The next one, right? 2.5 plus 2 times 0.02, right? Because that's my standard deviation. Okay, so that's going to be 0.02 times 2 is 0.04. 0.04, right? So let's do that. 2.5, 0, right? plus 0.04. There's a 4, there's a 5. The decimal comes down, 2. So that means it's 2.54. Okay. Okay, so we're almost there. Next, do you guys see a pattern? The next number is going to change. Like the 2, the 4, this should be 2.56. Perfect. Next one to the left, we're going to subtract. So we're going to have, why don't I go ahead and erase this? All right. So I have some room to show you. Okay, so we have 2.50 minus 0.02. Right? Since there's a 0 there, I have to borrow. This becomes a 10. 10 minus 2 is 8. The 4 comes down. The decimal comes down. 2. This is 2.48. The next one is going to be 2.46 and 2.44. Okay, so I finally labeled all of it. Am I done? Well, turns out I just dealt with the background information. I haven't actually gotten to the actual problem. But don't worry, the problem is actually super simple at this point. The problem here says, find the percent of these pennies that have a mass between 2.46 grams and that's supposed to have an N in there, sorry, typo, and 2.54 grams. So let's start with 2.46 grams. Let's locate this on our graph. This is our value. 2.46 is right here, right? Right here, right on this line. Then we locate the other one, which is 2.54 grams. Lucky for us, it's right here. It's right on that dot, right there. Okay, now if they want to find the mass between, right? They also want the percent. Well, all our answers are just going to be in percents. So we're going to take everything that's to the right of this value and everything that's to the left of this value, and we're going to just add it together. By value, I mean the percentages. So I'm going to take the 13.5 from here, right? So 13.5%. I'm going to add it to 34%. I'm going to add that to the other 34% that I see there. I'm going to add that to the last 13.5. And I'm going to stop there because that's where it told me to stop. They only want to know those. So if I add all those together, I actually end up with 95%. So what's my answer? My answer is right here. The problem is asking find the percent of pennies that have a mass between 2.46 grams and 2.54 grams. Well, if all this information is true, 95% of all the pennies in the United States that were made after 1982 have a mass in between 2.46 grams and 2.54 grams. And that's it. Yeah, I know. So over here, I wrote down all the steps to the best of my ability. Go ahead and screenshot this, save it. You don't necessarily have to write it down unless you're just like really confused, but it's here for you. So in case you're here, I'm just gonna fill in the information. This should be 95 and this should be 95 because that was our answer. And it technically falls within 2 standard deviations, right? I would be okay if you guys just told me the percent. If you guys went into all the trouble of doing this entire graph, right, to find the answer of a problem, right, I only need to see the graph and the percent for that answer. There's going to be a series of problems that you guys are going to do, and they're all going to have one to do with the same curve. So like, let's say I give you problems like 1 through 4, and all 4 problems are on the same curve. You only need to draw the curve once, and then you can give me the percentages for the last ones, okay, for all 4 of those problems, okay? So that's what I'm looking for the homework and practice, all right? You don't have to draw it for every single problem unless they change what they're talking about. And I'll go over a little bit more of that, okay? In your homework and practice for this week, there's going to be some keywords they're going to change the vocabulary. They're going to say, find the percentages, and you guys will just do what you just did over there. There's also going to be one that says, find the probabilities, right? And what that means, when they say, they mean the same thing. They want the percentages, right? Oh, that is terrible. Hold on, give me a second. Hold on, sorry. Just give me a second. Okay, better. I'm gonna draw this curve really fast. 1, 2, and 3. 1, 2, and 3. Okay. Let's say that they ask you for the probabilities that, let's say they give you a point. Let's use the same, kind of backfired. Okay, let's say that they're gonna use the word above and below. Okay, these are keywords you need to watch out for, because if they're not using the words within or between, they're gonna use the word above or below a certain point. Let's say I have the example from earlier. Okay, and then we have our percentages. .35. This one's 0.15. Again, this is 2.35, and then this is 0.15. All right, we have our percentages, and they're asking us, okay, can we go above or can we go below, right? Let's say they're saying, okay, well, what is the probability, right? They're going to say, what is the probability that a penny is going to be heavier than 2.52, right? So if they ask you for the probability that a penny will be heavier or will be above, I'm going to mark 2.52 because that's what they're asking for. And they're going to say, well, what's the chance of it being heavier than that? Well, heavier means that it's going to be bigger, and that means it's going to go to the right. So I'm going to mark that, and I'm going to say to the right, and I'm going to add up all my percentages to the right. That means to get my answer, to find out what is the probability that a penny will be heavier than 2.52 grams, I'm going to add up all the percentages to the right of 2.52. That means I'm going to add 13.5 plus 2.35 plus 0.15. All right, that's a 0. This will be a 10, 5, 8, 10, decimal, 3, 4, 5, 6, and bring down the 1. Guess what? The answer to that would be 16%. There's a 16% probability that a penny, right, from the previous problem, will be heavier or above 2.52 grams, okay? What if I want to know about below, right? Well, below means less, and that means to the left, okay? So what if I wanted to know below, what is the probability that a penny will be below 2.46 grams? This is an 8, sorry for the confusion. So what if it's below 2.46? What is the probability of me finding a penny that is less than 2.46 grams? Well, first I have to find 2.46 grams. It's right here. Below means less. That means to the left. So I'm going to move it over here to the left. And every percentage to the left of that point, I'm going to add together, and that's going to be my answer. So I'm going to take this 2.35 and this 0.15. So 2.35 and 0.15. I'm going to add them together. 10, 3, 4, 5, decimal 2. There is a 2.5% probability that I will find a penny that weighs less than 2.46 grams. And that's really all I'm looking for. Okay. Okay, this video went on for a while. Sorry about that. If you have any questions, please join me for the Zoom hours, right? So Zoom, office hours, 1:30 to 3 p.m. Link is in Google Classroom. Um, and yeah, I'll post up the homework. I haven't decided how many problems to do yet because this can take a while. So let me think about that and then get back to you guys. All right, guys. Good luck, and please contact me if you guys are having trouble.